In this episode, we discuss the application of Web3 technologies in the industrial Internet of Things and edge computing. My guest on this episode is Rex St. John. Rex has spent over a decade building developer relations programs at companies such as Intel, ARM, and NVIDIA, where he is currently building a global software ecosystem for NVIDIA Jetson. A quick thank you to our sponsors. This episode is made possible by our friends at HiveMQ, who are providers of an enterprise-grade edge and cloud-based MQTT broker. I use it for my own IoT applications, and they have a free version which allows you to connect up to 100 IoT devices. So please do check it out to help support this channel. Welcome to the 4th Generation podcast here on Industry 4.0.tv, which is a series of weekly interviews designed to help you learn industrial IoT from some of the world's leading practitioners. So if you're new here, make sure to subscribe and click on the notification bell to make sure that you never miss any of the interviews. If you find this conversation interesting, please review it with 5 stars on Apple Podcasts, follow on Spotify, and connect with me on LinkedIn at Kudzai Manditeresa. Now here is my interview with Rex. Okay, so Rex, I would like to welcome you to the 4th Generation podcast here on Industry 4.0.tv to discuss the application of Web3 in edge computing and industrial IoT. So welcome.
Thank you for having me, and really appreciate your making the time.
Okay, great stuff. So now, Rex, as you know, there's a lot of Web3 information flying around nowadays. Some of it obviously being some misconceptions. So perhaps we could begin this session by giving us a definition of what Web3 really is and what are the key drivers of Web3.
Absolutely. Before I get too far into it, I'll say these are all my own opinions and nobody else's. So once we've established that, I can talk a little bit about Web3. So there has been a very significant amount of discussion about what exactly Web3 is over the last few months. And I think there's still some disagreements, but some common trends that people can agree on is it's about the ownership of your data and your money, it all flowing to you, the user, and the community participant. So rather than outsourcing your identity or ownership of your videos or content or posts, all that stuff is going to be owned by you. It's going to live in your wallet. And it seems to be that the trend is towards moving away from necessarily APIs, everything being driven by APIs, to everything being centered around the wallet as a construct. So I'm going to own an NFT that represents my house. I'm going to own NFTs that represent my tweets and my content. And my wallet's going to talk to yours. So this is the direction things are heading in. Fully defining it would be a much longer discussion, I think.
Oh yeah, absolutely. Okay, so now from that definition and from your understanding of Web3, how will it impact edge computing and industrial IoT, particularly in the manufacturing space?
So I think we're in a context where we've had a decade of people talking about blockchain, blockchain this, blockchain that. And I think a lot of that discussion didn't seem to end up anywhere that people feel is productive, that they can point to and say, well, blockchain clearly enabled this particular use case that wasn't possible before. So I think you have to understand this context before we can talk about what has changed and what's likely to change in the future. So when I look online in the traditional silicon IoT edge computing space, I see a lot of people who are pretty burned out on the whole topic of cryptocurrencies and Bitcoin and blockchain. And their current read on the situation is that this is just it's a Ponzi scheme, it's a scam, and like nothing has happened here. But what I think they're missing is that some things have changed. And in particular, I would point to the movement towards these proof of stake algorithms that are being advanced by folks such as Ethereum and many others. Now, with this change, we're moving into a world where you no longer need to just fire up very heavy duty servers and hardware and then just run them to burn energy to crack these cryptographic problems which most of that energy, I think a lot of people would argue, is wasted just to provide the security of Bitcoin and other proof of work networks. So now what we're doing is moving towards some new algorithms, these proof of stake now algorithms, which are much faster, much more streamlined, much more lightweight, and they don't have this side effect of throwing away a lot of computing processing power, yet they're felt to be quite secure. So with this change, this enables, in my opinion, for the first time, some really interesting new use cases in edge computing and IoT. And I'm seeing a lot of evidence that this is an area that is growing and is likely to grow in the future.
Okay, that's interesting. Now, well, clearly the rate of adoption is not as one would expect for such a transformative technology. So, what would you say are the biggest challenges at the present moment with regards to the application of Web3 in edge computing?
I think there's a big usability and user experience problem. So that's the first one. Like, there's a lot of people that have spent all day long in these spaces playing around with decentralized finance and like swapping money and coins and things like that. So there's a lot of people that have gained a lot of these advanced skills. Yet, when I look to the broader public, like I think it's just going to be an incredible amount of lifting to move most people into this space, because most people don't have the time to be on Twitter and in Discord 24/7 learning about all these projects and swapping coins and securing their wallet. So there's just a massive usability gap. So I think that's the number one. And the second one, I think there's just a really big education gap. Like, again, this space is innovating so rapidly that even if you miss a month or two, like that's missing several years of innovation, I think, outside of this space. So there's education and usability gap that's just enormous.
Oh, okay, that's interesting. Now, well, for industrial IoT solution architects in the audience who may be wondering, like, how do you go about putting this into practice? What are the architectural approaches or methodologies that currently exist for Web3 implementation?
So let's talk a little bit about what seem to be the things that are true about Web3 that directly and realistically relate to IoT and industrial and edge computing. So I would say at this stage, like, I don't think you can look around and be like, well, blockchain is now powering this factory, like in a realistic way, or that blockchain or proof of stake algorithms are solving some problem in this use case. So I think that is just completely missing. But when we look around, what we start to see is, okay, here are the areas where this actually makes sense. Like, these are the things that are likely to be impacted in your world, and it will probably take a couple years before you really start to see it on the ground. So the first thing I would point to is the Helium network. So Helium was covered by the New York Times, I believe it was last week. And the gist of this article was, actually, maybe there is a use for blockchain after all. Like, that was literally the title. And what they're observing was that there's now over 500,000 of these Helium nodes. And what it is it's you buy effectively an industrial gateway. It's like a 1,200, 900 to $1,200, $1,500 gateway, and then you set it up in your house with an antenna, and you provide LoRa connectivity to your local neighborhood, and you mine coins with that gateway. And then what's following after that is you're starting to introduce other forms of connectivity. Like, I just got a 5G radio from Helium from a Freedom Fi. So now I've got like an actual 5G hotspot that I'm running out of my house to provide 5G connectivity to my neighbors. So it seems like this connectivity conversation is moving first. And this is the area that is currently being impacted in the IoT space. I'm not sure if I would call it industrial. So that is moving along. And then you can start to ask, what is likely to happen next? And I think what we're looking at in the future is a world where connectivity, compute power, storage, energy, and these kinds of resources that are provided by computers become exposed on an open network. It's an open marketplace, so that your excess capacity can be bought and sold. And that's going to have a lot of ramifications in the future.
Oh, okay, that's interesting. So from your description there, essentially, what I get is that this whole idea of Web3 is about decentralizing compute, connectivity, and also storage. So, like, are there any mature technologies or projects that you could talk to us about about?
It seems like decentralized storage is moving quite quickly. So these folks from Protocol Labs created something called IPFS, which is Interplanetary File System. And what this lets you do is kind of rely on a volunteer network of people that are providing storage so that you can use this as kind of like a distributed Amazon S3 in some ways. And you can back up your files into multiple locations based on whoever in this marketplace, because it is a marketplace of storage providers are able to provide. And then you're using in their case they're monetizing that, or they're paying people with these tokens called filecoin. So it seems like and there's other projects such as Arweave are I haven't fully studied Arweave, but they offer something called permanent storage. So it's like the idea that you store this file once and then it never goes away, and then you've got a guarantee that that's going to be there forever. So storage and connectivity seem to have moved first, and then there are a number of projects exploring decentralized compute, such as Gridcoin, Golem Network. There's several others that are doing this, where the idea is like, okay, I've got a CPU Flux, I've got a CPU lying around, it's not doing anything, so why don't I sell that to people? Another one is Otoy Render Coin. They're selling off GPU excess GPU capacity. So the compute conversation is coming along, and then you've got people like a cache network, and what they're doing is true decentralized web services, where you can, like, if I build a website, a cache and Dfinity and others, I can deploy that to volunteer computers and then pay kind of like tokens to have that website hosted by this network of volunteers versus like AWS or wherever.
Oh, okay, yeah, that's quite interesting, you know. And one other interesting concept is that where you mentioned in one of your videos where you talk about the fact that the iPhone was a success because Apple employed a business model that subsidized hardware to make it cheaper, so to speak. So maybe first of all, you could maybe start by explaining more about that, and then also talk to us about what sort of business models for subsidizing hardware do you envision for Web3 in the industrial edge computing space?
Yeah, so I mean, historically, the idea of installing hardware and writing custom software for it is a very big lift. Like, if I'm going to put some computer in some factory to solve some problem, you're looking at an extremely large expenditure, both on the software and the hardware side and the maintenance piece. Um, so what you're getting at there is a lot over the last few decades. You've seen a lot of slides and heard a lot of people saying, okay, IoT has arrived, there's going to be devices everywhere, this is going to be little computers and sensors attached to absolutely everything. And then the piece that didn't materialize is exactly what the business model is to finance and justify putting sensors in all those places. So the concept of, okay, well, there's computers are cheap, so they're just going to be everywhere gathering sensors, is like the first aspect of it, and the technology and the business models to do that are in place. But the thing that hasn't arrived is, like, how do you justify actually doing that? And that's what folks like Helium are showing, is like the hardware is actually going to pay for its own costs, and it's going to justify that based on the actual usage of that end hardware, the utility of it. So if I just spent $1,500 to put a 5G radio in my house, and in theory, that's going to pay for itself by the fees coming in from people like logging onto my 5G hotspot and then paying me to cover the cost. So in that world, the business model shift is that this hardware is now more directly able to be monetized and justify itself. And then as that trend continues, you can see a world where not only can the hardware pay off its own expenses, it can also pay to recycle itself at some point. It could be setting money aside from coins being used to pay into it. And those coins could ultimately be used to pay some vendor to come pick up the device and replace it and throw it away and like clean it up. So I think that kind of trend is coming.
Oh, okay. Great stuff. Okay, so do you have any like practical use cases of Web3 and edge computing in industry that you could share with us?
Storage is the biggest one. I mean, that one, like I'm talking to folks like Filebase and others, and they are seeing real demand for this, and I'm seeing that the economic calculation for using storage on networks like that make good sense in some cases. And I think ultimately it is all about economics and actual utility. Like people are really going to drill into this, and like they're not, no one's going to do this unless it really makes sense from an economic perspective. So from that perspective, like we have to be really honest about the current state of overall maturity. It's like, this is not going to happen tomorrow. This is going to take years. Like this
Yeah.
is this is going to take a while, but we're starting to see early evidence that this type of approach is going to be more common in the future.
Okay, yeah, that makes a lot of sense actually. So now there's also another interesting concept that I picked up from you, which is the distributed training of artificial intelligence models using Web3. Could you elaborate on that for us?
Yeah, so here's a good example of like a natural fit for this combination of technologies. And this is where I actually see this making sense. So with federated learning, the way it works is I, as a central organizer, have some model, and I want to rely on a network of people to help me train this model with private data that only they have. So that could be hospitals that have a lot of X-rays of tumors, for example. And those hospitals, due to legal regulations and other reasons, privacy concerns, they can't just send that data from the hospital to the central location so that you could train on that data. So what they do instead is they say, okay, I'm going to take this model, I'm going to send it to the hospital. I'll let the hospital train this model using the data that they have, and then the hospital will send me an anonymized, obfuscated, a version back of that model that has been trained. So you can see that this workflow forms a little bit of an economy between these hospitals and the central provider and the model. And this is a natural fit for a concept of, well, the hospital should be paid based on how much data they have, how much they train the model. They should be paid based on how much compute and GPU time they dedicate towards training that model. So they should be paid for that. And like you could pay that for that in a variety of ways, but one of the ways that makes the most sense is some sort of lightweight proof of stake currency that can keep track of how long did you train this model for. Okay, we agree it was 100 hours and it was 50 terabytes of data. So you get $20,000 from us, and we'll send that right to you from our wallet to yours. And then when you send the model back, then you get that payment. So that's a very natural entry point. And there's people that are there's I believe it's a company called IEX or iExac. They're actually doing that already. They're doing this kind of use case of federated learning with cryptocurrency payments. So that is one place where this actually all the pieces sort of make sense.
Oh, okay, awesome. Okay, so now to conclude this session, you had mentioned the fact that this is, we're in the early days here, but I would like to kind of get a sense from you of what you see as being the future potential of Web3 and edge computing in industry.
I think that we're heading towards what I'm calling a machine economy. And what this is, as I said, all compute resources are exposed on an open marketplace for buyers and sellers. And that includes connectivity, storage, compute, and energy. And in the future, I think this may also include, if not be run by, a market in carbon offsets. And I can talk about that a little bit later as well. So what this world is going to look like is anybody in the world, whether it be an edge co-location provider or an independent data center or an individual operator that has machines lying around, can download something and plug those machines into the network and say, hey, I volunteer this machine to accept external compute jobs either in my area or from wherever. Anybody who wants to send this, I'll do that work for you, and then just pay me in some shared currency. So one of the reasons that view of the world makes sense is the demand for silicon has been so extremely high. Like
Yeah.
people can't get enough silicon. Like you can't cars can't be produced because there's not enough silicon. So um, software is easier to write than the limitation on the amount of software we write is it's effectively unlimited until you begin looking at how much silicon is actually available to fulfill all the needs of that software. Um, so there have been a number of articles and studies done which show that 30 to 90%, depending on the data center, of these data center CPUs is excess idle capacity. I mean, these things sitting around doing nothing in certain data centers in certain locations. Now, if you're the CIO or CFO or whatever of these companies that have these idle data centers, you're going to start saying, well, if there were only a way we could keep these things busy 100% of the time, then that would be a better model for us than just having idle capacity. And we're starting to see companies exploring this. Like there was an announcement by a protocol called Anchor Protocol, where they had done a deal with a edge co-location provider to basically do exactly that. So this edge co-location provider says, "Hey, I've got 100 machines sitting around doing nothing, 30% of the time. During that downtime, I'm going to run these as Ethereum validator nodes, and they're going to get paid for doing that." So that's just the beginning. I think this world of wanting to keep all available silicon running full speed at all times is best possible through this model of this open marketplace. So I think that's the future, but I think getting there is going to take a while. I think there's
Yeah.
going to be several steps before we get there. That could be 5 years from now, but I think that logically is the direction I think things will head.
Oh, okay. Yeah, that sounds like a very interesting future there. Okay, so yeah, well, that brings us to the end of the session here. Thank you so much for your time. And if you've got any parting words for us.
I think that in the future, we're going to see a bigger push towards making sure all compute resources are available online. And again, I think the approach that makes sense is all that capacity should be on a open marketplace, a marketplace between machines where machines can buy and pay for themselves and pay each other, and users can pay to put workloads on those machines. I think it's highly likely that the metaverse itself may live on that environment and may be hosted using those types of methods. So I'm pretty excited about the future of edge computing and data centers and how all this is going to shape up.
Okay. All right. Again, thank you so much for your time, and wish you all the best in your endeavors.
All right. Thank you.